Hello and welcome to Computer Tech and More. Today we're going to be taking a look at the ROG Strix case fan. And this is part of my redone series where I redid all of my noise testing analysis on all the other fans. While we're going to be seeing this video, if you're new to this channel, I do recommend that you watch the second half of this video where I go into all the graphs and the details about why every test is important, what's being tested, and all that fine detail. If you're returning to this channel and you just want to say, hey, why are you retesting these fans? Well, this is what's going on. I've got the original testing methodology, I got the new testing methodology, the rank, the model, the RPM, and the performance, so the air speed that was achieved. On 100% PWM fan signaling, we have one extra column, and that is the noise level. So first up is the CPU air cooler test. Noise normalized, the XF120 ROG Strix was ranked 46th, is now ranked 38th, so a small improvement in position for that fan. At 100% PWM fan signaling through the CPU air cooler, it was ranked 41st and retains that position. A value proposition, noise normalized, it was ranked 45th. It is now ranked 28th, so a pretty significant improvement there. 100% PWM fan signaling, value proposition through the CPU air cooler, it retains position at 29th. CFM testing, noise normalized, it was ranked 27th. It is now ranked 12th, so that is a huge improvement. CFM 100% PWM fan signaling, it was ranked 22nd and retains that position. CFM testing, value proposition, it was ranked 25th, it is now ranked 14th, so again, a big improvement there. CFM testing, 100% PWM fan signaling, value proposition, ranked 25th. Case simulation test, 6-inch mark, noise normalized, it was ranked 46th, it is now ranked 30th, so a little bit of improvement there. The 11-inch mark, noise normalized, case simulation test, it was ranked 34th, it is now ranked 30th, so barely any improvement there. Value proposition, 6-inch mark, noise case simulation test, noise normalized, it was ranked 40th, it is now ranked 19th. Value proposition, 11-inch mark, case simulation test, it was ranked 34th, it is now ranked 24th, so a little bit of improvement there. So first up with the individual graphs is the case simulation test. It can be looked at in a couple of key different ways, but the most important for you, the viewer, is what size case do you actually plan on buying? So each of these data points is measured from the front of your case to roughly where your CPU socket is, assuming a front-to-back airflow design with an air-cooled CPU cooler. This is not for radiators, it's not for AIOs, it is assuming an air cooler or an air-cooled GPU. Either is applicable. So now let's get into each data point. The 6-inch mark is representative of a small form factor case that is still a front-to-back airflow design. The 6-inch mark is also representative of a short throw distance, meaning what I'm talking about here is air from the bottom of your case blowing up into your GPU. So placing a can at the bottom of your case, blowing it up, that is the short throw distance. The 9-inch mark is representative of a compact tower. A GPU, a case that is barely long enough to fit a GPU as long as a standard ATX motherboard. Something around that size mark is what I envision the 9-inch mark to be. Then we have the 11-inch mark. The 11-inch mark is your standard mid-towers. And then the 14.5-inch mark is just your big towers. Something like the Fractal Design Torrent. So looking at this graph, it doesn't tell us a lot of information. We need to move on a little bit. So now we're on to noise normalized, and I have what's my control fan. My control fan is 3 parts A12X25 to 1 part A14, blending together two very good fans. One for the 120 milliliter class, one for the 140 milliliter class, to create this composite fan to compare everybody else against. So fans that beat it, I would consider to be a good fan. Fans that are underneath it would be aren't necessarily bad fans, but would be considered suboptimal, just for reference sake. 140s tend to do better at the 11 and 14.5-inch mark, while smaller 120 millimeter class fans tend to do better at the 6 and 9-inch marks. So the XF120 is greatly underperforming my control fan. Let's move on. 100% PWM fan signaling, and it's still underperforming compared to my control. Let's see how it does against a subsample selection of fans that I've tested. So first, some notes. These are what I consider to be the good fans. So this leads us to the XF120. It starts off very close to the Wonder Snail, but it drops pretty far down. It's not good for case airflow design, and we knew that from its blade design. How about at 100%? Nope, it's not. So once again, it's just not very effective there. How about noise versus airspeed? Well, we see it towards the bottom of the graph, so let's just move on. Now we're looking at airspeed through the CPU air cooler. This should be where this fan actually shines, because of its blade design, it's more of a pressure-oriented fan. So let's focus on the left side. We got RPM versus airspeed. Airspeed is vertical, RPM is horizontal. In both these graphs, better fans are going to be sitting top left, worse fans are going to be sitting bottom right. And the XF120 is, at lower RPMs, not very good compared to my control fan. But as RPM increases, it aligns itself fairly closely with my control fan. So in terms of blade efficiency, it's overall not great. But if it, let's say, had a turbocharge mode, so it could achieve even higher RPMs, I'd be very curious to see how it could actually perform. And then on the right side, we have noise versus airspeed. So this is a noise efficiency graph, and we see that it's not particularly efficient in that regard. So that's a little bit of a downer for this fan, where it's just a bit too noisy. Now, how does it rank against a subsample selection of other fans I've tested? So very good, middle crowd, lower crowd. So the X12 or X120 is sitting right here at 0.9 meters per second of air. If you upgrade to the P12, it's now going to be pushing 1.3 meters per second of air. So that means for the same, for an unlocked CPU, for the same noise level, you're going to be able to draw a higher wattage. If your CPU is locked, you're going to be able to run your system at a lower temperature, or if you can take that extra overhead and pull back the PWM fan signal, so now your system will run quieter for the same thermal load. At 100% PWM fan signal, we see a lot of the same things, and we see that the XF120 is sitting well towards the bottom of the graph. Actually, right here, the legendary TLG12. The reason I bring up that fan is my top value pick so far, and it's tying it. So that's not a great result for the XF120. So how does it do in terms of noise versus airspeed through the CPU air cooler? Well, not great. So you might be looking at this line right here, and this is for the CF120HP, and it's worse than it until it's better than it. Interesting. But yeah, the XF120 is not looking so great. Okay, now we're on to CFM testing. This is my least favorite test in terms of how a lot of other reviewers use it. So CFM testing is really simple. You have a fan, it's the same size as the tube, you blow the air down the tube. So then where does this lead us? Well, look at that! The control and the XF120 are almost perfectly in line with each other. It proves my point. Let's move on. Noise levels, no surprise, there are going to be differences here. Surprisingly, the XF120 starts off a little bit better than my control fan and then drops behind it. Not terribly far behind it, but it is behind it nonetheless. So how does it rank compared to the other fans? Well, it's towards the upper part of the graphs, which is good to see. How about at 100% PWM fan signaling? Well, it's kind of in the middle bottom. So it's okay. Where's the A12X25? There it is. So the A12 is like 8 CFM, cubic feet per minute, better than it. So take what you want. And in terms of how it ranked in terms of noise levels, well, here it is. At lower RPMs, air speeds, it tends to actually be towards the top of the graph, like it looks actually at the top. But then it kind of starts flatlining, and it ends up towards the bottom of this. This sample selection is what I consider good fans. For the most part, except for the S12A, which is in here to indicate a much more poorly performing fan. Now we're in value proposition. The XF120 is a $20 fan. So value is a real simple calculation. It is performance per dollar. So airspeed divided by money. So the XF120 in the 6-inch mark is kind of at average, maybe slightly like a hair's width above average, but not really significantly. At 100% PWM fan signaling, it is well below average. For the 11-inch mark, it's kind of the under average, not great. At 100%, it's ignore it. Ignore it. Don't buy it, please. Okay, for CPU cooling though, here it's sitting just a little bit above average, but not significantly so. Again, the TLG12 is sitting right here. It's a great value pick. And then at 100% PWM fan signaling, it's average. I'm going to call it average. And we have the TLG12. It's sitting right towards the top. I need to bring this up again. Or maybe I didn't yet. Anyways, value proposition doesn't tell you peak performance. It does not tell you it's great performance. It is great performance per dollar. So for a CPU air cooler, I would recommend you look at the earlier graphs and pick out a fan that is high enough performance for your needs. If you've got a low-powered CPU, you don't need a high-end fan. If you're getting a high-end CPU, just spend the extra money and get a high-end fan. If you already got a cooler. Just saying. Okay. CFM testing. Well, here the XF120 did pretty well. It's well above average. So if you want to make your own at-home wind tunnel, apparently it might be a good choice for making an at-home wind tunnel. As for my personal thoughts for it, it's okay as a CPU or cooler, but it's nothing special. It's not even a great value overall. Right, at the end of every single one of my videos, I do like to show off my raw data. This data does belong to me. I am the one who generated it. It takes around 1.5 to 2 hours to generate this level of detail. So I ask that you, if you do want to use it in any sort of video or publication, written or journal or video, that you do reference me and my channel and that you ask my permission to do so before doing so. Because it's a nice thing to do. If you want to use it for your own particular uses, meaning if you want to just type it out into Excel so that you have it, so that you can check it against other fans, have it in the future, do your own calculations, you are more than welcome to do so. I'm always looking for constructive criticism in my videos, so if you've got ideas on how I can improve them to make them more enjoyable to watch, I am more than welcome to take that criticism. Oh, sorry, I knocked my microphone. Take that criticism. Just note that it may take a little bit of time for it to be implemented into my videos, and only constructive. If you're just going to spew hate, I'm sorry, I'm going to block you. It's just the way it is. I'm not trying to nurture that kind of community here. What else? Oh, if you want to see me test any fans in the future, please leave them in the comment section down below. I will try to get my hands on them. They do probably need to be sold on Amazon just for ease of getting them. But other than that, we'll go through whatever I can get. What else? Oh, hit that subscribe button, hit that like button. Really help me out with this channel. And if you like what I'm doing, you want to see this channel succeed, please think about joining me on Patreon. It really will go a long way in getting me that next step to acquiring this test equipment so that literally I'm competing with much bigger channels that have much bigger budgets than me. And none of them are aerospace engineers. Like, I have a background in fluid mechanics. So this is a specialty of mine. Like, I specialized in fluid mechanics. So I actually know what I'm talking about here. If you want me to do a detailed explanation of, like, the math, like full engineering course, let me know. I can try to put one together. It may be boring, though. Anyways, have a great day, and I hope to see you next time here on Computer Tech and More.